Okay, so the lesson for tonight is just an intro. Here a bit of everything. Okay? Alright. So first, what we will study is that other than angle in degrees, for example, if the angle here, okay, I believe you know how to calculate the length of A to B if you are given that the radius is 7 and the angle is 60, right? You know how to calculate. So you use 2 pi r times theta over 360. Okay, I believe all of you remember this. But then here there is another unit of angle. Okay, so what is the unit? Is what we call radian. Okay, 1 radian is when the length of arc, for example, this is 1 radian when the length of arc is similar to the radius. If this is 7 and this is 7, this is 1 radian. Okay, so how big is 1 radian? You can use this equal to 7, then you can calculate. Alright. So 1 radian, that is intro only. So what you have to know is that how to change from radian to degree and degrees to radian. Okay, so in order to change from 1 radian is 1 times pi over 1 times 180 over pi. Okay, so it will be 180 divided by 3.142. So it's about, so 180 divided by 3.142 is about 57.288. 57.288 degrees. Okay? So that is how you change from radian. So what you have to understand also, in order to know the whole circle is 2 pi radian is 360 degree. Okay, 2 pi. So when you divide by 2, you get pi radian is 180 degrees. Okay, so this is 3.142 radian will be half of a circle. So you can divide. Okay, so in order to change from radian to degrees, you multiply by 180 over pi. So and then for example, you have 60 degree. You want to change to rad. So it will be 60 times pi over 180. And you have to know that sometimes the answer would be, you have to multiply something like, you use pi as 3.142. So 60 times 3.142 over 180. So it become 60 times 3.142 divided by 180. It become around 1.0473 radian. But then sometimes the answer could be, they ask you to give the answer in term of pi. So you just 60 divided by 180, you get 1/3 pi radian. Okay, take note of the changes. Okay, how to change from radian to degrees to radian. So most of the question, when I will try to answer, in case the angle is given in degree, so I'll just use this formula. Okay, if you want to know the length of arc and you know the degree, I will use this. Okay, And then when I want to know area of this sector, what is the formula when you were in Form 2? You forget? Pi r square. Okay? Pi r square times theta over 360 on the condition that theta is angle in degrees. Okay, alright. So now, using rad, you could calculate the length AB here using the formula S equals to R times theta. This is S is length of arc. Is it clear? I'm using the red one. Is it clear? Okay, right. So S equal to R theta is length of arc, is radius times theta. Theta is angle in radian. This R is radius. Okay? And then, in order to calculate the, for example, area of sector, using the formula in radian is, area is 1 over 2 R square theta. This is for what? For sector. Again, this theta is in radian. This theta is in degrees. So which one you prefer? I do not prefer any one of them. Just look at the info, okay? But on the condition you have to memorize the formula, because these formula are given in the maths exam, not in the maths exam. These formula are given in the maths exam, but not these two formula. Okay, so it really depend on whether you memorize or not. Okay, so but usually I would prefer that you use whatever given. Okay, so easy, right? So what other thing that is important here? Just to find all the values. Let's say you want to calculate. They ask you to calculate, and then they don't give you directly everything. Okay, so for example, they give you that the length of arc is 7, and then they will tell you that the angle is 1 radian. So how do you calculate the area of sector? For example, you want to use this, but you need to know what is the radius and what is the value of the theta. Okay, so now, using whatever the info we have learned so far, let me show you, maybe you turn the page to, for example, okay, look at page 7. Do you have the textbook? Okay, you do not have. Okay, if you do not have, so I will show you question number, for example, question number 2. Okay, page 7, this is self exercise 1.2. There's a circle. Okay, if not clear, let me know. So the length of arc here will be 1.284. 1.284. Of course, 1.284, of course, it is in radian, because 1 radian is 57 degrees, around that. Okay, so it cannot be 1 degree. Okay, so and the length here is 25 centimeter. And how to find the radius? Okay, so question A, what is the radius of the circle? Okay, so what you have to know, you have to find the angle around here. Okay, so what do you know so far? 360 degree is 2 pi. 2 pi means 2 times 3.142 is 6.284 radian. Okay, so 6.284 minus 1.284, then you will get 5 radian around here. Usually we write as rad only, R-A-D. Okay. Alright. So in case this side is 1.2, so this side is so I should just to reconfirm, Arifah, is it clear? 5 centimeter and okay, you can read that. Okay. Alright. So this is 5 radian, this 25. So we use this formula, for example, because we know depend on the info, because we know the angle in radian, you use this formula. So we say 25 is equals to 5 times theta. So theta, R, okay, R times 5, because R theta. Okay, theta 5 is radian. Okay, this theta. Okay, so R we do not know. So R is 25 over 5. So R is 5. Okay, so if notice, it's 25. Okay, so the radius is 5 centimeter. Okay, so that is the answer for A. And they want to find the minor length of EF. This is EF for info. Okay, Arifah, EF, the length is so the question B, question A is asking for the radius, question B is asking for what is the length. So use this again, but now the angle is 1.284. Okay, so S is length of arc. Okay, S is length of arc. We want to know the length of the small arc. Will be R is radius is 5, and the theta in radian is 1.284. So whatever it is, so 5 times 1.284, so 6.42 centimeter. Okay, alright. So any questions so far? So I think I erase this. Okay, so what is other than important part of it? Because this is purely for introductory to the circle. So usually the question will not be totally on the circle. Okay, so sometimes they give you shaded region. Shaded region, it will be, for example, line like this, the segment. How to find the segment? Sector minus triangle. Okay, so it will involve other chapter. They will not just asking you about this thing. So they make it complicated. This chapter is very easy, but they will make it complicated by giving you maybe trigonometry, that you have to use trigonometry, sin, tan, cos. Okay, so that is what you, for example, you are given and they want perimeter of the shaded region here. So you need to know the length of AB, the straight AB, and the length of arc AB. Okay, so how to find the straight line of AB? 7 here and 1 radian here. 1 radian is 57.288. How to find the straight line here? It is related to the formula of triangle. That is, what is the formula? A square equal to B square plus C square minus 2BC cos A. Okay, so cos A. So you can find the length of here. Alright, so you can use the AB is 7 square plus 7 square minus 2 times 7 times 7 times cos. This one you have to use the angle in degrees, 57.288, and you find the square root of the value. Okay, could you read this? Is it clear? Okay, Alright, so 7 square plus 7 square minus 2 times 7 times 7 times cos 57.288. That is 45 point something, and then find the square root of it. So it is 6.71 centimeter. Okay, and the arc AB, it will be arc AB is using this formula S equal to R theta. But since you know the angle in degree, you could also use this formula. Okay, so but usually this is easier. S equal to R theta, radius is 7, the theta is 1, so the arc is 7. So the parameter, you just add the two, it will become 13.711. Okay, and maybe they will ask you about further up, it will be about area. Okay, area of shaded region. Okay, area of shaded region will be sector. This sector. This I'm talking about this as a shaded region. So area of sector AOB minus triangle AOB. Okay, so the formula in order to find area of sector is half R squared theta, half times 7 squared times 1 in this case, then you get 49 over 2, 24.5. Then the triangle AOB is 1 over 2. So how to find the triangle? This is related to the triangle that we learned last year. Is it last year? Maybe this year, okay? But maybe last school terms, okay? Solution of triangle. What is area of triangle? 1 over 2 AB sine C. Okay? This one you do not have to memorize because it's given. But if you memorize, that's much better. Okay? 1 over 2 AB. AB is the two side. 7 times 7 times sine. But this one, sine angle must be in degree. Is it a must? Not really actually. Is it? Can we use sine 1? Yes. If you press calculator, make sure your calculator is, the setting of the calculator is in radian. Okay, there is a setting calculator. Okay, let me show you. You press mode again. They come up is DEGRADGRA. So you do 2 red. Okay, so for let's say the calculator setting is in red, then you can use the same thing, 1 over 2 times 7 times 7 times sine 1. Okay, but I do not really encourage this. Why? Because I myself forgot sometime I changed this to red. Then when I use this, I forgot to change back. Okay? Then all the answer will be going haywire. Because calculator, I'm calculating according to 57.288 red. That is how many circle? Because one circle is only 6.284 red. So 57 means 1, 2, 3, 4, 5, 6, 7, 8. Something like 8 circles. Okay. Right. So since I do not encourage, I come back to use that degree, then press 1. Okay, then I use this one. That is 1/2 times 7 times 7 times sine 57.288. That is 20.61. If this is centimeter, this is centimeter squared. And then the shaded region will be 24.5 minus 20.61. That is okay, small. Okay, so the shaded region here will be, the shaded region is only 3.89 centimeter square. Okay, so basically that is the most important about the new topic. But again, as I said, we are going to do the exercise because you will discover you need more knowledge other than this. You are going to apply whatever you have learned so far about sin, tan, cos, formula of sin in the triangle, formula cos, formula area of triangle, and many more, which I cannot explain. Not until we look at the question, each and individual question. Alright, so I'm going to ask you to do some exercise here. That is okay. So for those who have the textbook, you turn to page 10. Okay, page 10. We are going to do each and individual question. For those who doesn't have textbook, I'm going to send you the question now.